So this is the 2015 Leaving Cert Ordinary Level Paper 2, and we're looking at question number 7. The diagram below shows the right angle triangle ABC, which is used in the logo for a company called Dean Construction Limited. The triangle PQR is the image of ABC under an enlargement. So we can see here we have our triangle ABC and we have the enlargement here. Part A1 says construct the center of enlargement and label it O. So the center of enlargement, you can do this by joining corresponding points. So the point Q corresponds to the point B. So if we draw a line from Q through B all the way back there, and then we do the same from another two corresponding points, so P and A correspond. If we join them back through each other like so, wherever these two lines then meet, that would be the center of enlargement. So they meet up here at this point here. So this point here would be the point to mark O. You can see it there, the lines going back. You could also join from O to C, and that should also meet there, but all you need to do is two of the lines. So that's the center of enlargement. Part A2 says measure in centimeters the length of the line OB and the length of the line OQ. So just with a ruler, you measure those two lines, and the values you should get: OB is 15 centimeters and OQ should be something like 22.5 centimeters. If you got slightly different values, they usually allow you to get the answer within a certain degree of accuracy. So whatever values you get, they're the values you will use for the rest of the question. 22.5 centimeters is what I got. Part 3 says use your measurements to find the scale factor of enlargement correct to one decimal place. So OB was 15, OQ was 22.5. So OB was 15, that's OB. And then we had OQ. From here all the way down to Q, that was about 22.5. Well, the scale factor of enlargement will be one of the long lengths divided by the small lengths. So it's going to be 22.5 over the 15. So when you do this in your calculator, you get a value of 1.5. So that's our scale factor of enlargement, 1.5. Part B says the area of the triangle ABC is 7.5 centimeters squared. Use the scale factor to find the area of the image triangle PQR under the enlargement. Well, this scale factor we found here is sometimes called the linear scale factor. So if the linear scale factor is 1.5, and we're looking for the area of the big triangle here, the linear scale factor will always be squared to give the area scale factor. So in other words, if the linear scale factor is 1.5, well then the area scale factor will be 1.5 squared. It's always the linear scale factor squared. So we're just going to multiply our 7.5 centimeters squared by the area scale factor by 1.5 squared. So when we do that in a calculator, we get 16.875 centimeters squared. That's the area of the larger triangle. Part C1 says, given that AB is 5 centimeters, use the scale factor to find PQ. So let's go back to our diagram. If AB is 5 centimeters, if we have a look here, if this AB is 5 cm, we want to know what's Q here. So to go from the small triangle to the big, we're going to multiply by the scale factor. So it'll be 5, this will be 5 times the scale factor, so 5 times 1.5, and that gives us a value of 7.5. So PQ is 7.5 centimeters. Given that QR, the length of QR, is 8.7, use the scale factor to find BC. So if QR is 8.7, we have QR here, if that's 8.7. So remember, from 5 went to here, and this time we're going from the 8.7 and we want BC. We want the length of BC, so this time we're going backwards to here. These are corresponding sides. So this time, if we're going from the big triangle to the small one, we're going to divide by the scale factor. So it's going to be 8.7 divided by 1.5. And that gives us a value of 5.8. So 5.8 centimeters is the length of BC. And finally, part 3, hence show that the size of the angle ABC is equal to the size of the angle PQR. So hence means using what we've just done. So can we show this using what we've just discovered? So the size of the angle ABC and the size of the angle PQR, we have to show that they're the same. So the size of the angle ABC, so that's this angle here. You have to show that it's the same as PQR, which is this angle there. Well, if we look at this triangle here, ABC, we've got this angle here. It's in a right angle triangle. So what information do we have? Well, if this is the angle, we have the adjacent side and we have the hypotenuse. So if we think of SOHCAHTOA, we have adjacent and hypotenuse, that means it's cos. So we can say that the cos of the angle ABC is equal to the adjacent 5 over 5.8. Well, we put 5 over 5.8 in our calculator. That simplifies to a fraction of 25 over 29. And down here, if we do the same for the angle PQR, the cos of the angle PQR is the adjacent, which is 7.5, over the hypotenuse, which is 8.7. And if we put that in our calculator, that also gives us a value of 25 over 29. So we can see then that the cos of the angle ABC is 25 over 29 and the cos of the angle PQR is 25 over 29. So if the cos of the angle ABC, the size of the angle ABC, is equal to the cos of the size of the angle PQR, well then the size of the angle ABC will be equal to the size of the angle PQR. Both of them are acute angles, so we can say that. And that's the end of part C and the question.